Welcome to part 2 of 2.6 part 1, rational functions and their graphs. Our essential questions are the same as they were before. What is a rational function? How do you graph a rational function? So we're going to look at something called arrow notation and use arrows to describe the behavior of some functions. So your first one, x arrow a to the positive, means x approaches a from the right. X arrow a to the negative, x approaches a from the left. X arrow infinity means x approaches infinity, so x increases without bound. And x arrow negative infinity means x approaches negative infinity, so x decreases without bound. I would take a snippet or copy this down in your notes in some way. You can pause the video and do that now. So, definition of a vertical asymptote. The line x equals a is a vertical asymptote of the graph as a function f if f of x increases or decreases without bound as x approaches a. So we're going to look at our arrow notation at the bottom. You have x approaches a from the right. So when x approaches a from the right, f of x goes to infinity. When x approaches a from the left, x goes to infinity. In this situation, x approaches a from the right, f of x goes to negative infinity, and when x approaches a from the left, f of x goes to negative infinity. So your vertical asymptote, x equals a, your line will never touch it. So locating a vertical asymptote. If f of x equals p of x over q of x, and it's a rational function in which p of x and q of x have no common factors, a is a 0 of q of x, the denominator. So when x equals a vertical asymptote of graph f. So we're going to go over an example which will make this a little more sense. So it says find the vertical asymptote of any graph of the rational function f of x equals x over x squared minus 1. So there are no common factors in the numerator and denominator. So now we need to set x equals 1, or x minus 1 equal to 0. So if we were to solve this, this means x would be plus or minus 1. So your vertical asymptotes are the lines x equals 1 and x equals negative 1. So zeros of your denominator are negative 1 and 1. Thus the lines x equals negative 1, which is your red dotted line to the left, and x equals 1, your dotted line to the right, are your vertical asymptotes. So that means your x values can never be negative 1 and 1. So in this next one, it says find the vertical asymptotes, if any, of the graph of this rational function. As we went over last time, we had a similar problem to this. So we have x squared plus 1 equals 0. X squared equals plus or minus, x squared equals negative 1, so x equals plus or minus I. This is not a real number, so remember, you would not have anything in the bottom that would equal 0. So in this case, you won't have any vertical asymptotes. So we cannot factor the denominator of h of x over the real numbers. So the denominator has no real zeros, thus the graph of h has no vertical asymptotes. Make sure you complete the questions below, watch the next videos, and then move on. The next video will discuss horizontal asymptotes.